Thank you. Thank you for having me. So, as Marco said, my name is Jorge, and we'll be talking about unit testing. I've been doing training and consulting for, since 2013, and I was helping mobile developers from both teams and individuals to teach them the best practices when talking about mobile development. And that usually means architecture, continuous integration and continuous delivery, refactoring, and what brings us here today, which is the automated testing. In this case, we're going to talk about unit test views, which is usually a topic that people tend to ignore. And while doing all these trainings, and I've been traveling from one country to another, I have been, this is a very rewarding experience because I've been traveling to many places in the world, and I love to hear why people do tests. And so I would like to share this with you before starting the technical part of the presentation. I have always been interested in knowing what brings people to unit testing. One of the most common answers that I usually get is because they are told to do so. I mean, like, some of the companies are forcing their employees, and I think that's not bad, to learn and practice unit testing, but they are not really motivated to do so. Another common answer is peer and team pressure. And let's be honest here. I mean, you are not cool if you are not testing. There's not going to be a party after this in which we can meet face to face thanks to COVID. But at the end, what we are going to have here is conversations in the chat, and you are not going to be cool in the chat unless you know how to do tests and start a good conversation about testing. So this could be your starting point. Another thing that is very common in terms of reasons for testing is, particularly if you work for a consultancy company, is that the company has agreed to do a percentage of coverage. I mean, that the code is going to be somehow covered with tests, and that is the measurement that is one of the deliverables that they have to give to the customer. And probably the most appealing one, forgetting all the technical ones that you probably have heard many times, is avoid embarrassment. And I totally buy this one. I think that we should avoid making mistakes over and over. And instead, we should put tests in place to have these things behave, our applications behave as expected, and not to reintroduce mistakes that we did in the past. As important as it is to know why you test, I believe it's also important to know why you don't test. So one of the things that I believe is also, well, here I'm just kidding, but not so much. People tend to say that they are doing some testing, but they give you any excuse to tell you that, yeah, I am ready to do testing, but I don't, just because, okay? So I don't think that's a good excuse. Go and learn to do some testing and do it in every application that you have. Another thing that is important is that avoids people from testing is that they perceive that testing consumes time and effort from their main goal, which is delivering the actual application. And like any other thing in life, it takes you longer the first time you do it, but once you have learned how to do this, it's always, in my opinion, you become far more productive than if you are not doing tests. It takes some time, but the code that you deliver is better. You spend less time debugging. So at the end of the day, I don't think it's bad from the perspective of being productive. Another thing that they claim is that it is hard. It is too hard to do testing properly, and also that they don't fully understand how to do it. And the purpose of this talk is to at least give you some ideas to avoid having that perception about this being hard or not understanding how it happens. So let's go with it. Let's go with the agenda. And I'm going to share the agenda with you. That was the agenda that I originally planned for when this conference was going to be delivered, well, half a year ago before COVID, or right at the beginning of COVID. And I was planning to do an overview, give you some implementation details, and I was planning to share with you and write the code with you together. I mean, like, I would write the first one, then we can write the second one all together. Sadly, this doesn't work that well for a streaming conference, so I decided to go with slides, but please feel free to ask as many questions as you want afterwards. I would love to listen to the details and share any additional knowledge that I can have on those. Okay, so without further ado, let me start with a brief introduction to what we are going to do and the context, and then we will go and write the test. Okay, so initially we're going to cover architecture because we're going to assume that I'm going to have an application that helps us test it. And I know what you're thinking right now. Oh, yeah, but my application is not ready to be tested. My application has dependencies that are hidden. My application is not well constructed. It's not well organized. It's not even using any particular pattern, or the patterns is a mix and match of different patterns there. Yeah, but this is on your to-do list, and this is some technical debt that you should be solving. And let me tell you something. If you put some effort into doing testing, you will force yourself to make your architecture better. But let's assume that we already have something that somehow can be tested, and you will see that it's not that difficult. It will come as no surprise that MVVM is the architectural design pattern that is most common in the Android world. And this is because when they introduced their architecture components, correct me if I'm wrong, but I believe it was 3 years ago, they implemented MVVM for their platform. And it is going to be even more relevant when we get to Compose, and Compose becomes the default, de facto interface for Android. So if you are not into MVVM yet, after the Droidcon, after this session today, go and learn how to implement it. I'm going to give you some hints here so you can take advantage of those and use them for your implementation later. So what you have in MVVM is basically 3 parts in regards to every view that you have in your application. Obviously, you have the view that is the one that is responsible for getting the user events, the user information, and the system information too, and share it with the view model. And the view model acts as a model to the view. So it has properties representing the state of each of the views that you're going to have there and changing those when needed. And in order to let the view know, it notifies the view of any changes on those properties. Obviously, the purpose of the view model is not just to show the information or to give the information to be represented to the view, but also to transform those user events into something that is meaningful for the model. I mean, like, I tap on some create button, and then what I get is that the model creates some instance of some entity that I'm using in my application. Well, so in this model, you have some operations that will be invoked by the view model, and should the view model subscribe to the model, it will also be notified on any relevant changes on the data there. So for example, if you are talking to a remote web server, and the model is downloading things from the persistence from that web server, when the new data arrives, it will notify the view model that there's new data there. Okay, so in the case of architecture components, that means that we have a room there for the persistence, for an implementation of the model that could have additional logic there. And we will offer some operations to the view model that are built upon the room classes. And in the view model, we're going to have some class of the view model, and for the views, we're going to have activity and fragments. And more fragments than activity, to be honest, because I mean, like, the way we're going to is to use fragments for every view, and navigation through fragments is the preferred way to go nowadays. And in order to notify those changes in the data, we're going to use lightning. That is a standard. I mean, like, I haven't done anything particularly different here, so you should be tired of watching something like this. So let's go into testing. In the case of unit testing, we first want to address what I mean by unit testing. And I'm pretty sure that most of you know what I mean, but just to put everybody on the same page, this thing that is called the testing pyramid, and what you have in an application is commonly a set of unit tests. These tests are testing things in isolation. So they test individual pieces. This is like if you were building an engine and you're testing the individual screw or individual bolt to see that that piece works as expected. It does what it's meant to do. So it doesn't test the whole engine. It does test only this piece. And that is very important because it makes this piece to be tested for its purpose, not for its integration. We do have integration tests. We do have some tests that are meant to be running not just a single piece of our engine, just not a single piece of our application, but some of them. It doesn't have to be all. You can talk to your views and use your view models, or you can talk to your view models and check their persistence. So you are trying to address the different parts of this in order to see how well they integrate, how well they behave. And usually you try to avoid dependencies on external systems here, but you want to have the integration test as the test that tests more than one thing in your application. You, on top of that, you have acceptance tests. And the acceptance tests are meant to go with your customer and say, we agree that this application is going to be that and that. And let's see that it does exactly what we are expecting to. There are some others, like smoke tests, that are similar to acceptance, that avoid you further embarrassment. But the important thing here is that the more things that you put together, the weaker, the more flaky the tests are, and the less you probably are going to have. In the case of unit tests, you can have, like, for every single method of your classes, you can have a unit test or several. So this is what we are going to focus here, and we're going to talk about testing the views. But before getting into testing the views, let me go a little recap onto what to do when you are testing the model. As I said before, the model here is represented by a room class, and what we are going to do is addressing how to do the testing of these room classes that we have commonly in every application. The application that I've chosen for this session is a T-ranking application. What do I mean by that? Well, I don't know if you share my taste, but I love tea. I also love coffee. And love chocolate. So every exciting thing is good for me, and coffee and tea are awesome. But coffee, you usually buy similar brands. I'm not that picky, or maybe I don't know good places to buy different coffees from. While tea, you have very different flavors, very different kinds of teas, very different mixes. So to be honest, I go buy tea, and they give me some testing for future buys, and then I arrive home, and when I go back to the store to buy those teas, I have completely forgotten whether I like that or not, and whether I should get another test back for that one, or I have already tried. So I decided to make a tiny application to keep track of the tests that I have done, or the teas that I have tested. And in order to do so, it's pretty simple. I have a list of teas, and when I add a tea, I will add it to the database, and I add it together with a rating. The rating will be like stars. I mean, like you have 1 star for something that you don't like, to 5 stars, which is something that you love, okay? And here I'm going to do that simple thing. This is a crude application. It just creates, reads, updates, and deletes things. And in this case, it's going to be using the pieces that I mentioned. It's going to use fragments with fragment navigation, view models, and room for the persistence. Okay, so let's talk about the persistence again, and about how to do this with a model. So the model requires some, it's probably the easiest thing to do testing, to be honest. I mean, like most people tend to start by testing the model. And sometimes they claim that this is enough because the logic, the business logic of your application is mostly concealed in the model. However, I totally disagree with that. I mean, like, I believe that the user experience as a whole is what the user is expecting. It's not expecting that your model knows how to do the right calculation, but that when the user taps on something, it behaves as expected. So the model is only a part of it, and you should test it, no doubt about it, but it's not the only test that you should focus on. The thing here is that testing the model, as I said, is usually easier, and there are well-defined operations, and you do the operation and you assert on the results. Let me go back for a moment. In case you're not familiar with unit testing, every unit test that you're going to write is going to have 3 parts. So the first part is called the arrangement. It's the 3 A's. There are other ways to call this, but for me, it is easier to remember the 3 A's. So the first one is for arrange, second one is for act, and the third one is for assert. So in the test, you will be arranging things, you will be preparing the scenario for the testing, then you will be acting on the method, on the object that you want to test, and finally, you will do some assertion or some assertions. We can talk about that later. But the assertion is like, if I have this scenario and I do this, I expect this to happen. That's why some people say, given, when, then. This is how they call the AAA instead of the given, when, then. So that's the alternative. Go with the one that you prefer, but the idea is here, you prepare a scenario, you do something in that scenario, and then you expect something to happen. You expect some results. The results can be the output of a method, the state of the object, or some lateral, some side effect on some other object. So in this case, in the case of the model, it's usually pretty easy. We have some operations that are defined, and then we will be doing assertions on the results. In some cases, if we are going to do a notification on changes on the model, for example, as I was mentioning before, and if I were downloading the data of the TIS from some application, I could bring the data here, and then when the data is here, I could notify on that. And I would be connecting to the model in order to observe those changes. I don't have that test in the slides here, that could be easily done, and I have a similar one that I can mention later. And finally, it is important to keep in mind that what you're testing is your own code. It is not a Google's code. It is not a third-party code. You shouldn't test any generated code. It is important that you focus on the code that you have created, and anything that is going to be generated is somebody else's problem, not yours. The only reason you may have for testing Google's generated code, for Room, for example, is if you want to prove that there is some bug there and you are asking them to solve that bug. That would be a good reason for creating a test on some code that is generated by somebody else. In this case, would be Google. So this could be a very simple entity. Notice here that there's a very similar, very simple one. You have the T, as I was mentioning before. There is a table for the T's. That's an annotation from the Room library. And I have defined what is the primary key here, So far so good, and there are a few properties. I have an ID, I have a name, I have a rating, which is how much I like the tea, and the date in which this data was stored. So, well, so far so good. I also have some business logic. For me, a T is not valid unless it has a name that is not empty. It has to have some characters. I could be pickier about this. I could say it should have at least 3 characters, and I remove the spaces before checking that. Whatever you feel like. But there's some validation logic here, and I'm also measuring that the rating is between 0 and 4. So anything that is between 0 and 4 is a valid rating. 0 means I don't like it. 4 means I like it a lot. So between this range, all the values will be valid. But if I have a -1, as I have in the default value here, you will see that that is not something that is acceptable for your model. So the idea here is to assess whether this class is testable or not, this data class in this case, and I claim that it is, and it's perfectly testable. What you are going to test here is that the values by default are set. You're not setting the behavior of the default values encoding. What you're setting is that by default, a class is providing you with the values that you expect. You don't care how it happens, if it happens with default values of properties or in any other way, but you want to test that. Also, and more importantly, in my opinion, you would like to test the validation logic, because this is business logic of your application. You want to be sure that when you have a T, it is not valid unless these rules are followed. Okay, so let's write the test, or at least let's see it. What we have here is the skeleton for a test. If you were writing code in Android Studio, you will do Command-Shift-T, I believe. I have muscle memory, but it's terrible at remembering the muscle memory with names. I believe it's Command-Shift-T, and it will ask you to go to the test class that corresponds to that class, or to create one if it doesn't exist. So I have created one here. As you can see on the screen, it has a variable for the SUT. SUT means system under test, the thing we are testing. In this case, we are testing the T class. So there is a setup here. I create a T instance in the setup, and the first test is very dumb, but usually it helps to know that I didn't make a mistake when creating the T for the rest of the test. You can skip that one if you feel like. I usually put it there. The test that we would like to write is that the default T is not valid. I want to be sure that when a T is created by default, I cannot save that one. Why? Because I want the user to put data in. I don't want to create dummy instances of tests that are added to the database. So I want validation to fail by default initially, and only when the right data is added to the T, then I will be glad to create a T and add it to the database. That's pretty easy. We have already set up the scenario. We have already arranged the thing. We have a SUT instance that we can test here. And there's no additional thing to act on. There's no act part, because the act is the creation of a T. What I'm going to claim here, what I'm going to assert, is that it is false that the T is valid. So that's what I write there. I call the test default T is not valid. The name should be very telling. It should be explain what the test is doing, because when you are running hundreds of tests, when something fails, you want to know what part of the code you should go to. So if the name of the test is clear, it would be very helpful for you to go to the right part of the code and try to solve any issue that you may have there. Okay, other than that, the last part, the assert, is the assertion that I was mentioning. And if I run this, obviously it will pass. All the tests here are going to pass. I'm not going to say that again, if I can remember that. But let me go with the last one. The last one here is, as the name says, T is valid with no empty name and some valid rating. Okay? So what I'm going to do here is create a different instance of the SUT. So I create a T, but in this case, I'm going to add a name to it, and I'm going to add a rating. The rating is going to be valid, the name is not going to be empty, and I now assert that the T is going to be valid. And that's what I need to do in order to verify my T entity. Pretty easy, isn't it? Okay, what else do you usually have when you're running a room database in your application, a room model? So usually you have a data access object, DAO, and in order to do that, you have this. You have an interface that will allow you to do all the usual operations, to create, to get, to fetch the list of T's, to update the given T, or to delete one T from your database. Notice that there's no functionality here. I mean, yes, there's the description, the promise of something to happen, but the implementation of this functionality is not going to be done by you. Rather, it's going to be generated for you by Room. So, is it your responsibility to test this? No. This is not testable. This is not some code that you should write here, but this is the code that is required in order to generate the proper functionality in Room for your database. Same thing happens with the Room database. That is the way you create the database. Well, there are far more advanced things that you can do here, but this is a fairly easy one, and for the purpose of this example, I believe it's good enough. And here you define which kind of objects you work with, and whether this is the version that you are using, what is the latest version that you're using, so you support migrations and so on. And what you define here is a method to create that. But notice one thing, this class is abstract. There's no way to create an instance of that. It is actually Google's Room's implementation of your database, the one that is going to derive a database using that class. So again, we can have a discussion about subclassing this one and testing. I don't believe it's worth. So I would say that it might be testable, but I don't think you should spend the time on testing that one. Okay, so that is a summary for the model. That's a very brief view of what you can do in terms of testing in a Room model. I agree that it's a very simple one, but I believe that it contains enough pieces for you to understand how to do that for a bigger one. Now let's go with the view models. And what we're going to do now is testing the view model instead of the model. And for that, we have to, let me remind you what the view model does. So it accepts input from the view, and when it does so, it transforms those inputs into some meaningful behavior. So it provides meaning to user events. When the user taps on the plus button, it creates a thing in the model. You see? So this translation from user behavior into meaning in the model is done by the view model. Not only that, it offers some representation of how the view has to be displayed, and what it does with that is when it changes, it notifies the view using live data in this case. Same thing happens with the model. The view model is responsible for calling the model. You should never call the model from the views. And it is also subscribing, in some occasions, to the model in order to accept notifications of changes in the model. Keeping that in mind, what we're going to do here is we're going to use a mock as the model, because we want to see if anything is changing here for so when we do some action and we transform that action, we provide meaning to that action, and we invoke some part in the model, we want to know that this model is there and that we can verify whether it was called appropriately or whatever. So that will be the first part, to have a mock for the model. The second part is to get the inputs, and the inputs are going to be either the user events that have been produced in the view, and those are represented as methods in our view model, or the notifications that come from the model about changes that have happened there. And finally, we're going to try to cover the outputs of this view model. The outputs are the state, the properties that are offered as the representation of the view. So I want the view to have this test in this field. I want the view to have this color here. I want this button to be enabled or disabled. All this information are those properties that I was going to verify using the test. And finally, we have the operations. These are outputs that are the transformation, the meaning that is provided to the user events. When the user taps on something, it will change, it will operate on the the model and invoke one or more of its methods when required. So, having that in mind, let me show you a very, very brief view model. And what we're going to do here is something that is trivial. I have a this view model, and what I have there is a single method that is going to be called when the view taps on, the user taps on the view on the plus button. So when the add button gets clicked, then I will invoke this method that is going to be taking me to navigate to the next view, the one where I will be entering the name of the T, the rating, and so on. So when I do this, when something happens in the user interface, that user interface will call the view model, it will call this method, and this method has to trigger navigation. Navigation is triggered here using live data, actually an event of live data. I'm using Jose Alcerreca's implementation of that, and I'm using an event that is consumed only once, so you cannot reuse them, those navigation events. So I want to be able to say I'm navigating there, but once I've navigated there, the event is no longer usable, okay? So that the purpose of that navigate to t-edit live data is to expose that situation regarding navigation to the view. Okay, so how do I test this part? Again, pretty easily, what I'm going to do here is add a method for testing. I have created an instance of the view model, and the test is going to be called add button click emits navigation event. So what I'm going to do here is pretty clear. When I invoke that method, it emits a navigation event that is shown to the view. So in the arrange part of this, I'm going to create an observer. The observer is going to be a mock of what an observer would do. You know that an observer is called on change method and with the new data. So what you're going to have here is a mock that offers this onChange method. And I'm going to use this mock object, this fake object, in order to observe changes on the navigate to t-edit live data instance. That is my arrangement. What do I do for an act? I tap. I use the method that would be called when the button is clicked. So by invoking this method on the view model, I'm going to trigger the action. What do I expect? Well, that would be the assert part. I'm using a Mockito argument capture. This is called the Mockito, but what it does is use the verify to check that the onChange method of the observer has been called and capture the data for that for when this method is invoked. And what I want this to be is that the assertion at the end claims that the value that is used in order to call the onChange method is true, which means navigate to some other view. It's that simple. Arrange, act, and assert, prepare the observer, use the method that I want to test, and verify that the event is triggered. trivial for Viewmodel, and this is what you have there. Finally, there's one piece that I want to mention that you have to add. There is this rule there that will provide with a proper asynchronous, I mean, it would transform asynchronous behavior of the live data into synchronous in a way that this test can be run without any problems from the user interface. Keep in mind that here, running this unit test, my goal is to never create an instance of the emulator with an actual running application. I'm trying to run everything here in the application, in the Java virtual machine without running the emulator. So finally, let's go with the part that I believe is most appealing, that is how to do testing of the views. And in this case, I mean the activities and the fragments. What inputs do I have in the views? Well, I have changes in the properties in the view model that are going to be notified to the views, and I have the user interacting with the views. So the user will be tapping on a button, for example, in this case, in order to do some action. The outputs, what are going to be the outputs? The outputs are going to be the changes that respect on the view. It can be there are changes in the state, so a button is disabled or enabled, or it navigates somewhere, or it does anything that is related to the view, or it calls some instance of some method on the view model instance in order to transform that into some meaningful action. Okay. So let's go first with the activity, and keep in mind here that the activity is an empty container for the fragments. So most of what I'm doing here is pointless. What I have here is the activity, and what I would like to test, you will see that this has view binding and all the, I mean, this could be quite recent code, but the idea here is that it's very simple, that most of the action is going to happen in the fragment. The activity is just a container, as I said. And what you have here is not doing anything other than verifying that I didn't make any mistake putting the pieces together. I want to be able to be sure that when I launch the activity, nothing happens. There's no exception generated because I forgot to configure the proper XML or because of any other reason regarding the configuration of the activity. So what I'm going to do is to test that I have the activity launched without any problem. And for that, I create a simple test. I'm going to call it activity can be launched without throwing an exception. And I use a JUnit notation to say, hey, what I expect is that there's no exception coming out from this method. And I use the ActivityScenario to launch the activity using its class name. That, using Robolectric, should be more than enough in order to launch the activity empty. I mean, like without any additional context. That is usually the biggest problem for testing views, that you require some additional context in order to make them live, to bring them to life. So what I need in order to run this properly with Robolectric is that first I have an injection of the parts that are required here. I'm using Coin here because I believe it's a very simple solution, very easy, and it provides me with enough power to do anything. But the same thing can be done with Dagger, and it also can be done with Codeine. So choose your poison. Doesn't matter. I believe that this one is simpler, but if you prefer to go with anything else, I don't think there's much difference. I have implemented the 3 of them in different ways. So yeah. The thing that is important here, besides the proper injection of dependencies, is that you're running this with the proper runner. You want Robolectric to be run as expected, and since I'm using Android X libraries here, I want the Android JUnit for runner. If you're running a JVM version that is 1.8, like the one that is embedded in the latest Android Studio, at least the latest stable one, and you're running SDK 29 or higher, then you will need to say in some way that the SDK that you want to test is lower than that, because it requires JDK 9 in order to run properly. So if you're not using JDK 9, you should uncomment one of the 2 lines. The first one would use just a P as the version for the code, while the second one would try different options up to P, okay? So that will be for the activity. That is all you have to do in order to run Robolectric, to launch your activity and verify that there's no exception coming out from it. Okay, pretty simple. This will be something more complex. So in this case, we're going to test this fragment. And I know that it's not extremely complex, but it does some things. So you will see here that first it has some dependency injection here. And this dependency injection is one part that we will have to address. Then it does have the ability to create view using view binding, and it defines how to navigate by observing the navigate to T-edit event. And finally, it offers a listener for this floating action button, that is the plus button that I created in the activity. And when it does so, it invokes the view model, the method add button click of the view model in order to transform that into some actions. Okay, so let's try to go with the easiest fragment test first. And in order to do that, I'm going to keep the runner as I was doing. I'm still using Robolectric, and this fragment test is going to just verify that the launch of the activity, of the fragment is done as expected. And this is very, very, very similar to what I was doing with the activity. Not only that, I probably want to have a little bit more, because I want to be sure that the dependencies that I was using here are replaced by something that doesn't affect, that I'm testing this in isolation. I'm testing just the fragment and not anything else. What Robolectric is going to do is going to run this fragment in a container, in a synthetic container that is going to be good enough for this fragment to run, but it doesn't know all the dependencies that, as I showed you in the previous slide, are injected there. So what I'm going to do is to provide a mock for the dependency that I want there. You can see there in the line that starts with the @mock annotation that there is a view model mock there, and that is a mock of the TLS view model, the one that we saw before. And we also have live data that is going to be shared. So the purpose of this is going to create another module for injecting this fragment that is going to be based on coin as the original one, but it's going to override, as you can see there in the module line, is going to override the original one. And what you have to do is to use this one instead of the other one and run every test with this mock in order to use it for each of the tests. In this case, we're going to say that whenever the view model mock navigates to edit, we are going to then return navigate to edit in this case. But initially, that is not even required. So that is enough for testing that the fragment launches without any problem. And the only thing that we have missing here is that you have to be sure that you make the case of closing coin injection so it gets refreshed as new for the next new test. So using AutoCoin as a subclass of the TLS fragment, or sorry, the other way around. TLS fragment test should be a subclass of AutoClose coin test. That is what you should do in order to be sure that you can inject properly in each of the tests. Second thing that I would like to do here is coming back to the fragment. We're going to test this part. We're going to test that when the user taps on the button, it invokes the method of the view model that is expected. In this case, a button clicked. And obviously, we're not going to use the actual view model because that will be harder to test. We want to test the fragment in isolation. So that's why we created the mock of the view model, and that's why we are injecting this using coin. So the second test that I'm going to show you here is going to be that the add button invokes the view model add button click method. Okay, so how do I do this? Well, I'm assuming the same setup as I had before. So what I'm going to do is just add an additional variable. Is going to be a late init because it's going to be initializing the setup, and is this SUT, the instance that I'm testing, the system under test. And I'm going to create an instance of this in the setup. So every time I run a setup, every time I run a test, I will be creating an instance of the fragment. And what I'm going to do is, once I have this, I don't need any arrangement. The act is going to be look for the view that has the ID TFAB, so the floating action button, and perform a click query. That is provided by Espresso. Espresso can run with Robolectric, and this is what I'm doing here. And the assert is going to be verifying that in the Viewmodel mock, I have invoked the add button click. That should be it. That goes for the second fragment. Let me go with the last one, and so we can close in time. And in this case, what we're going to test is that it navigates to another place. And in order to implement the navigation, I need a navigation controller, as you can see here. So in the test, I'm going to inject another property that is going to be a navigation controller that I'm going to create here, this navigation controller. And the navigation controller is going to be provided via the injection into the same method as before. So when I have this navigate to edit, I provide this value, that would be my act, and I expect the navigation controller to be invoked with this same value of the thing. So some implementation details, and we'll close this presentation. I was using Coin here, as I mentioned. I believe it's very simple. First they override, which makes things simpler to do the injection in the test. And it provides the module with the mocks, which is what I was expecting. And it has this auto-close scoring test class that is useful to inherit from in order to do the test. As for the rest of the things, I was using Robolectric 4.4. And I was using the runner from Android JUnit4, which is in the test extension JUnit. I was using Java, in this case 11, but Java 9, so in order to be sure that I was running Android Q test. And you can either do that or use the config SDK, at least for Java 8, and go with the configuration annotations that I mentioned. And obviously, you need the Espresso actions and matchers, depending on the test that you want. The goal here is that everything runs on the JVM. You don't want the emulator to run, because you want this test to be as fast as possible. And they are slower than the model ones, but they are far faster than if you run tests on the emulator. Finally, I don't intend you to read this part. It is for reference. I will publish the slides later in case you're interested. And just follow my Twitter, which is down there. And if you're interested in the slides, you can get the dependencies. I didn't put the versions here because combination changes every time. And to be honest, it's a pain to keep a combination that works perfectly for you. One thing to remember is that you should enable the MockMaker part to do inline injection and use the latest version of Mockito. It doesn't matter. Don't assume that calling Mockito is going to bring you the right dependency, and remember to configure it to make inline injections. And that should be it. I hope this has been useful. Thank you very much. I really appreciate the Droidcon organizers to bring me here. If you have enjoyed the presentation, this is my data. Feel free to post anything there. And if you have any questions related to this, I would be more than glad to answer them. Feel free to send me a message now or later. And that's it. Thank you.